This pipelines are attached to the cartridge.
Yes, it is already attached.
Oh, when the pack
It
is
comes
open,
as a yes,
the
yes.
cartridge.
We cannot remove this any of this.
So this filter is also attached to the cartridge.
Yes.
If you want to change the filter in the
We
entire
can't change.
cartridge.
We have to enter filter along with the tubing.
Oh, so for CRRT we have to select the filter, then the cartridge will come with the filter.
Yes. Okay. So no need to purchase this tubing separately. We can't able to purchase like that.
Only cartridge.
Only cartridge. Because the
What is
almost
the cost of this cartridge?
MRP is 18,000.
Okay.
So the last what it is saying, open the effluent.
So if one filter goes for suppose 12 to 24 hours.
Yes.
So once the filter clots, the entire cartridge
Yeah,
has to be removed.
entire
Yes.
system
we
you
have to
change.
throw it. In HD we have only that filter.
Yeah.
We can just
Correct.
clean it and we can fill the disinfectant.
This
But here
M100
it is, there are
usually, how
multiple.
long you'll get?
That is depends on the anticoagulation we use and patient anticoagulation.
I feel
Usual target is 48 hours.
72 hours.
72
If
hours.
anticoagulation is there, easily we can run. But still, I used around 6-7 days also continuous. In Delhi, somewhere they are using even 9 days also with the citrate anticoagulation. But still, it depends on the patient. So if the flow is good, okay. The major factor is the blood flow. Okay, so blood flow is good, access is good, we can run it easily.
Any possibility of reuse?
No reuse because in HD we are doing maybe
Reusing.
4 hours, maybe after 2 days only. But this is continuously running, and maybe we are not giving any anticoagulation. And in ICU, maybe those patients are maybe their coagulation profile is disarranged. And after 24 hours to 48 hours, we can't able to reuse this filter.
Oxalis? How
Even
long?
Oxalis also. Oxalis also
3 days.
3 days, 4 days. If
That usually
it's
doesn't
not
work
clotting,
in
we can
24
use even 5 days also. Okay. But the Oxalis effect of that absorption will be around 12 to 24 hours. Okay. But still, we can use as a CRRT filter. Okay.
Now, to this, if you want to add cyclosol, suppose, how do we do that?
You can connect here. Okay. We can remove it.
Free filter put the cytosol, and then post cytosol you can put to the filter.
Okay.
You can remove it. You can connect cytosol on it. Other end you need a separate connection in between. Okay, because it is not suitable for the other end.
Okay.
So we can connect it. Okay.
So that connector, how do we get?
Cytosol will provide maybe.
He'll provide, is it?
Okay. But we are not suggesting
Yeah,
to
we are not
use. But
suggesting.
instead of that, you have Oxalis filter.
So Oxalis same cartridge will come with Oxalis.
Oxalis filter, the design
No
is
need
look
for
like
the
this
separate
only,
filter.
but the membrane inside is different. Okay, so the membrane in here is AN69, but in Oxalis AN69 plus PA polyethylene imine, and the AN69 is a charged AN69, so that will absorb cytokines, and that PA polyethylene imine will absorb endotoxins. Okay, and since it is a this semi-permeable membrane, it will give our convective diffusive levels also. Okay, but that absorption capacity will be around 12 to 24 hours. Then after that, it will become saturated. Then that also depends on the patient baseline this toxins. Okay. Then after that, we can run as a CRRT. Okay. So here we are connected. We have to connect this bag, effluent bag, along with all the filters. On bag also
But
will come.
after the Oxalis is saturated, is there an option to just remove the cartridge and put another filter, or remove the entire set again?
Entire setting.
Okay.
That will also come like this.
Okay.
Okay, so my suggestion is, if you are doing Oxalis, maybe 12 to 24 hours that will become saturated. Then if the patient need RRT, we can continue. Then give a break. Okay. Then start the another.
New Oxalis.
Not immediately after the next Oxalis. We can give a break till the time again that rebound. If a rebound will come, that will happen. Then we can remove after 24 hours or 12 hours after a gap.
We can continue CRRT.
Yeah, we can continue.
Only that adsorptive part?
Adsorptive purpose function will be maybe less. The peak time is 12 to 24 hours. Okay, we are connected all these things. We are connected this cartridge we kept, then this pressure ports, then this line. We no need to click here. If he knows, we can do that. Okay. Then press loud. If you are pressing loud, it will be fixed in the this part. Okay, in the pump segment. Okay. So before loading, we have to make sure these lines are open. So if it is a new filter, we are not going to worry, just to click on it because it's already primed, so saline in this. So you have to open this. Take a cover from here. Okay, if it is a new filter, no need to keep it like this because already primed and the saline in this.
As it is priming, usually to complete the priming process, it takes at least 40 minutes to shift the
For
machine.
me, I need 25 minutes, but for all new,
Is there a way to make it fast? Because many a times we want the patient to be on CRRT immediately, but then it takes at least 40-45 minutes
No,
for it to
because
actually
the-
start.
yeah, this connection and all, now I explained, that's why I took this method. In a 2 minutes, I will connect this. Okay, no, 2 minutes also I am not required. But the priming purpose, it needs 6 minutes, compulsory. Then the test, it takes around 10 minutes. Okay, that is compulsory, that 15 minutes is compulsory. Anyway, in 20 minutes, we can connect it if we experience it. So now, the machine identified which filter we are connected with this. It is M100. If I am connecting M60, that will identify. Here there is a barcode reader, so that read it is M100. So we can confirm that. Then next is we will prepare and connect solutions. We are connected the filter, then prepare and connect solutions means the priming solution as well as this dialysate and replacements. Okay. So here also we have steps. Okay. So what saying first, you can, if you need, you can just keep it here, just as a for securing this. Okay. Then second is connect priming solution. One more bag is there. Yes. Okay. Ah, here. So for the priming, we need 1 liter saline. Exact 1 liter, the priming will become completed. But now I am using this one. Okay, so do not use this because it's costly. So we can use our normal saline 1 liter. Because this line is already I hanged here at the time of this connection. This access line along with the effluent. Okay. Connected with saline. So we have a spike to spike it if it is saline. Okay, that I removed from here. Okay. Then next is connect citrate bag in the pre-replacement. Okay, here it is. In the white color scale. This is called Prisma PBP citrate solution. So that is called incomplete. Okay. So Regosit comes in a single compartment. Okay, this bifossil and Prismasol comes as 2 compartment. Okay, because our same thing in our HD also we kept their part, that is electrolytes and bicarbonate separately. So here also it comes as separate. While using only, we will mix this together. Okay, but in Regosit no need because there is no electrolytes. Okay. So this is a citrate solution. Okay, then along with the citrate, we use calcium-free dialysate. Okay, that is called bifossil, not Prismasol. It is almost the concentration is same as Prismasol, but the calcium is 0 here. In Prismasol, it is 1.25 or 1.75. Okay. So because we are giving this citrate, okay, to chelate the calcium. Then if you are giving the Prismasol, again that calcium will go into the circuit.
It has got phosphate.
Phosphate, yes, phosphate. So I'm connected with the bifossil solution for the dialysate. Then in the post replacement also we say you have to use bifocil only, but now I am using Prismaflex. I have to use calcium-free solution in the post replacement also.
Usually dialysate and replacement are the same.
Yes, bifocil. So now one L6 dialysate connected, then replacement also connected. Now what it's saying, connect. This is Prismaflex. Okay. So we can connect the return line. Now this line is not connected with anywhere. Okay.
No.
I will tell that. Okay. So now this line is free. So this line what is connect the return line to the collection or effluent bag. So this is the effluent bag. For the therapy time, this will connect to the patient, and this yellow line also will come here. But for temporarily for the priming only, we are connected like this. Connected. Then what it's saying, clamp the syringe line on the set. Okay. This is the syringe line. Okay. In the new set is become open. So we have to close it because we are no longer using this line. We are not giving any heparin. We are directly giving the citrate to the calcium to the patient. Okay. So then we have to continue. We are connected these three solutions with these same color coding lines. Then this return line we are connected with the effluent bag, and here we are connected 1 liter saline. Okay. In exact 1 liter, if it is 500 ml, in between we have to change it. If it is 1 liter, in 1 liter solution, the priming will become complete. Okay. Now I am continuing. Okay. Now it is asking for the calcium. Okay. So if I am doing that, we have selected that external calcium syringe pump. This step will not come. This directly it goes to the priming. Okay. Now we have selected Prismaflex syringe pump for the calcium infusion. So I will take calcium gluconate neat in this syringe, 50 ml. Maybe if it, I think 25 ml no, per ampule, or 10 ml, 10 ml only. So 5 ampules. Then I will connect this line. This is called CA250. This extra we need to purchase if you are using this machine for giving the calcium infusion. Okay. To bring this down, we have to press in the auto down, that plunger. That option will be available in the next step. Okay. So I connected the syringe, then auto up option will be there. Okay. Then close it, then continue, and confirm. Then we'll go for the prime, for the filter. Now this we are primed, this calcium line. Okay. Prime. So while starting the therapy, we'll connect this to the patient CVP also.
You need to prime first and then only prime plus test.
Prime plus test, if I am choosing prime plus test also, that will take the same time. Okay, if I am priming, then after that I can check is there any air, or I can just analyze, then I can go for the test. Both will take same time. After the priming only it will go to the test. Now this will prime in next 5 minutes. So this will count down for 4 minutes, 3 minutes, 2 minutes, 1 minute. Only we are suggesting with externally to give.
Spike it and then give it on.
You can add in this potassium easily
Okay, but not
in the Prismaflex. But phosphate, bicarb, all these things, it is better
Phosphate,
to give.
what you are at?
But we have options. Somewhere I am doing that also.
Add
Bicarb
first.
we can-
That is available here, but most of other countries it's
one
not
day,
available.
how many bags
There is a fleet,
For one
Nima
day therapy?
fleet.
That will be 10 bags.
That-
10 bags.
that's
10 bags.
Yeah, that.
10 bags on filter. Next day onwards, we need 10 bags. This filter
This
not
filter
required.
depends.
Okay, the first day around 50,000 is the consumable cost. Second day onwards, this 30,000.
Is there any possibility that you will bring in the other Prismasols here?
Other
Just
Prismasols?
B0 is available.
Yeah, BC
BGK 22, 4, all those things. Is
no,
it-
B0 and B2 and B4, the difference is potassium.
Yeah.
Okay.
So are you planning to bring it or?
No. As of now, it is not there. The reason is Now this priming is completed, I will tell you. Now we will go for the test, prime test. Okay, still we have two options, reprime, manual prime if required. But now this is fine, there is no error, then we can go for the prime test. Okay, now so your question, now the difference in the potassium. Okay, so you have in your hospital, in dialysis, maybe you have 50 bags of 0 potassium, 50 bags of 2 potassium, 50 bags of 4 milliequivalent potassium. Staff maybe they use 2, they maybe use 4.
Yeah.
They will in the consumption in the system they will put maybe in the 0. Okay, 2 will be there, 2 will not be there, but in the system 2 will show. Okay, it's difficult for them it is to manage also because it's look like almost same. So that is one reason. But if it is 0, we can whatever. If we need to make it 2 milliequivalent, we can.
You
make
can
it.
add
3 milliequivalent, we can make it. It's accurately. It is not like in HD machine because in HD machine we are making that concentrated solution that is mixing with around 34 liter of water. So here we have 5 liter of Prismaflex. If you are adding 2.5 milliequivalent, 5 milliequivalent of potassium in a bag, that
Getting
will
1
increase 1 milliequivalent. Okay. For the 5 milliequivalent, we need a 2.5 ml of potassium chloride. Okay. If I am adding in this bag 2.5 ml, the concentration will be 1 milliequivalent. If I am adding 5 ml, the concentration will be 2 milliequivalent. If I am adding 7.5 ml, concentration will be 3. If I am adding
So
10
like
ml,
that we have to-
1 ampule, that will become 4 milliequivalent. Just usually,
So
as
that
usual,
we
we
can
can add 4.
add.
Okay, if the patient is not hyperkalemic, almost patients are hypo only, that's where the CRRT is. So we can, in protocol we can make it, or we can add 10 ml, that is 20 milliequivalent in each bag. So 20 divided by 5 liter, we will get 4. And also, it is not easy to bring one more solution to it. Okay. So that is the reason.
So we can do mark with this machine only, no?
This machine only. We have to attach that Mars monitor with this machine. Now the test got completed. Okay, test completed. Now we have a chamber here. Okay, this we can adjust. Okay, because if the air, if little bit air is coming, it will accumulate here. This is the deaeration chamber. If you are not increasing this, it will go to the over air chamber. Okay. We can adjust from here. Then confirm the level. Okay, in between therapy also we can adjust that. Okay, while connecting, maybe some air comes, there is a chance multiple times we are removing. Then we can, in between therapy also we can adjust this.
What is the optimal level?
Here there is a mark. Okay, at least make it. If some air will come, then in advance we can make it till here also. Okay, that will accumulate over here. So continue. So here there is a, now we are going to the prescription. Okay, I will tell the prescription separately, but in the machine I will show you. So here we have patient fluid gain, loss and gain. Okay, patient fluid loss and gain 400 ml per 3 hours means in this machine there are multiple checks. Okay, because we are giving replacement into the patient body. Okay, if I am giving 1000 ml of replacement in an hour, how many liter of solution I am infusing into the patient? Around 24 liter per day.
Yeah.
Okay, that is average. Maybe that is 30 liter, maybe that is 20 liter. So we have to remove that exact 24 liter. Okay, otherwise in the ICU patients, if I remains 1 liter of I am extra, I am removing 1 liter, that will be a challenge. So the machine is again rechecking. Okay, at that time there is a chance of some deviation. That deviation is this. Okay, maximum if anything happen 400 ml per 3 hours. Per hour around 130 ml. Okay, so in our HD machine, suppose okay the UF is not removed. When we will come to know, once the patient while going they will give gali, then only we will come to know their fluid is not removed. But here at a time, because the patient is in the ICU, okay, we have to check. But so there we are not giving any replacement, only the dialysis, nothing is going into the patient. Maybe the negative pressure it will goes into the patient, but here we are giving a replacement into the patient. Okay, so for that it is by default we set in this 400 ml per 3 hours. Okay, if I am giving 0, that will give alarms. Okay, got it, na? So I am confirming that. Then here our prescription is. So in prescription we have blood flow in ml per minute. We can make it 150,
Minimum?
200. Minimum it's 10 from 10 ml at start, but We have to keep at least 100.
50.
100.
100.
Ah,
Okay.
because the blood stasis
Leads
and
to-
it
correct.
leads to clotting. So I keep
100.
130 or 100,
Okay.
100. Okay. Then dialysate. I'll tell you how to calculate this. I'll just keeping on 800. Replacement, that is post replacement.
Okay, post.
Yes. 400. Then patient fluid removal, that is UF. UF it is named as patient fluid removal. Okay. That is also per hour.
400.
Okay. 50
Oh,
ml per
okay,
hour,
50 ml.
maybe 0 ml per hour, 100 ml per hour. If patient tolerate, we can gradually increase the ultrafiltration also. Then I'm confirmed. Now this is asking for the anticoagulation. Okay, anticoagulation we chosen. If we are chosen heparin, here the heparin syringe pump, how to adjust that option will come. Okay, how many ml per hour. Okay, but here now we are chosen this one, Rijocit, citrate. So citrate we are calculating in the name of citrate dose. Okay, in this machine it is available on 0.5 to 6 millimole per liter. So here now 3 millimole is the usual dose as per the studies. If you are giving 3 millimole per liter, that will be adequate anticoagulation. Okay, but still we have to check the calcium and we have to adjust this. If the filter calcium is increasing, we have to increase the citrate dose. If the filter calcium is decreasing, that value I will tell you. The filter calcium will be in between 0.25 to 0.5. Okay, if it is less than 0.25, we have to decrease the citrate dose. If it is more than 0.5, we have to increase the citrate dose. I'm confirming that, and this is the calcium compensation. Okay, that is 100%. Okay, if the calcium compensation is, if the patient calcium is still less, not in the filter, in the patient ionized calcium is still less, we can make this 100 to 105 or 110. Okay, that is delivering from here. Then hematocrit which we kept is 33. That is just popular. Confirm all. Then here on screen will come how much citrate load which is going to the patient. Okay, that I continued. Then here the total prescription for the review. Okay, how much, what is the blood flow, what is the PBP citrate, what is the dialysate, what is the replacement. Okay, I'm continuing. Now we can connect this to the patient. Okay, how we will connect? We will remove this replay our effluent line, and we will connect this to
Return.
the effluent bag.
Bag.
Okay, yellow connect to the effluent bag. So these are the two lines which is connecting to the patient. So just consider this is our patient. Okay, patient has two axes. Okay, one arterial lymph and there is a venous lymph. I'm connecting these two. Just assume this is a patient axis line. If you want to remove it, we can drain it. Otherwise, we can connect together. Okay, connected. So this is our patient. So I'm just starting. Continue. Start. Now the therapy start. I will show you the line and the alarms and troubleshooting and the prescription. So this is clear, no? These two
Yes.
lines. So this is the axis line which is coming from the patient in red line through this red line. This small line I will tell you in between. Now you just see this red line. Okay, blood is coming. It has come to the axis pressure port. Okay, so axis pressure is negative only usually. Okay, in our estimation also, but we are not monitoring. If you are monitoring that, we will come to know the exact patient
So negative.
pressure, and we can manage some fistulas also if it is, we are monitoring that. Okay, but we need a separate tubing for that. Okay, so this is axis pressure. Then it comes to the blood pump. Okay, from the blood pump, this goes to the filter. Okay, so before filter and after the blood pump, there is a pressure, this pressure pot, that will measure the filter pressure. Okay, if the filter there is some clot, this will increase. Okay, then now blood is in the blood inlet. The flow is like this. This is the blood outlet. Okay, blue in color. Blue in color. Okay, then this goes to the deaeration chamber, then air detector, then line clamp, then to the patient. This is the blood circuit. Blood circuit, got it, no?
Yes.
Red line, access pressure pot, blood pump. Now the speed is 130 ml per minute. Then our filter pressure pot. Then dialyzer blood in, dialyzer blood out, chamber, because chamber comes in the return pressure, return venous line only. Then only we can trap the air. Then the air detector, then the clamp, then back to the patient. Okay. Now this line is
Effluent.
no white one. Pre-replacement of citrate line. So here we had Rejosit, that is citrate solution. This is coming to the this pump.
Okay.
From this pump, this comes out. It is just
Okay.
attached with this. Okay, not attached. Just stick. We are not directly connected. Then this coming to the access this end.
Okay.
Okay, so this is the pre-replacement as well
That
as it is a citrate line. If it is an anticoagulation is our citrate, that will work as a anticoagulant line. Otherwise it is as a pre-replacement. Also it will work as a dilutant. Okay, if it is heparin free, if you are increasing this one, the blood become diluted and it comes to the filter. So this line, this scale, this line and this pump is over. Okay, now we have dialysate line. It will collect dialysate from there, and the speed I kept is 800 ml per hour. Then it comes to this pump. This pump will suck the dialysate and it will give to the dialysate compartment. Here it connects. Okay, we are in HD, we are connecting that coupling because machine is preparing that dialysate solution. Here it is already prepared ready-made solution that will enter into the dialysate compartment. That pumps over. These two we are covered. Now we have replacement solution. So replacement solution, purple line from the purple scale, which come to this pump. It will come here. This is post replacement. If this is coming here, pre-replacement. Just remember, I will tell how we are moving post and usually we keep, if we are using this line, if we are using this pre-replacement, we always keep this as a post replacement. Okay. So this is done. So these three completed. Now the solution, all the solutions which we are given in the patient circuit as well as in the patient blood vascular region. So we have to remove all this. Okay. So that will start here, the yellow line. Okay. So all these three are giving into the circuit. This we are taking from the circuit. Then blood leak detector. In case rupture, that blood will escape into this line only. No? This is the drain. This is the effluent pump.
You will have to calculate the effluent pump speed.
Yes. That no need, that I will tell. Separate. I will tell. I will come to this. Okay. Now this come to the or bag. It's completed all the circuit. Got it. So these four pumps, these three pumps will take these solutions and deliver in the different areas. Okay. Dialysate will deliver to the dialysate compartment, replacement deliver to the replacement. The circuit means the extracorporeal circuit where the after the filter, and this will give to the before the filter, and this one will take all the solutions from the and drain to the bag. Now we have prescription window. Okay. In prescription, blood flow is 130 ml per minute. PBP citrate, that is the flow of this solution, 1300 ml per hour. Okay. and the dialysate is 800 ml per hour and replacement is 400 ml per hour. So total how much till now? 2100 plus 2500, right? So 2500 solution is now in the circuit in an hour. We have to remove 2500 solution in hour to the effluent. Okay. Now how much it is?
2570.
2500 and
Adding the UF
70.
50 ml.
50 ml is the
UF and calcium.
effluent. I think 70 ml is the.
Oh, 50 is the UF and 20 calcium.
Yeah, and 20 ml is
20
the
is calcium.
calcium. Okay. So 2570 is the effluent which is coming into the bag in an hour. This is not fixed by me, machine calculated.
If you
I
have
given,
machine will calculate.
yes, I given this rate, dialysate, replacement and fluid removal. So machine calculated. So from this pump you can identify
The dose
how
is very
this.
high.
Yeah,
If
that
the
is
dose-
very high. I just patient weight take up to 60 kg. That is why that we can decrease it. Okay, so that I will show you the exact dose after on prescription. I will set it. So from here you will come to know how the CRRT works. This is the blood pump.
Blood pump.
Which pump is the highest speed?
Blood pump.
Effluent.
Which one? This one.
Influent. Yeah.
Then which is next to that?
Pre.
This one. Next.
Next dialysis.
Dialysate. Next. Replacement. No. Replacement. Okay. Because this pump job is have to remove 2570 ml of fluid from the circuit in an hour from the circuit to the bag. Okay, this pump is only 1300. This pump 800 ml have to take and deliver in the dialysate compartment. And this pump is 400 ml delivered into the in the replacement. Okay. And 50 ml we can how this is removing. The dialysate is directly coming into the from here to here. Okay, and this now the actual ultrafiltration happening is 1300 plus 400. How much it is? 1700.
So blood pump should be the fastest because it is in minute.
No, blood pump is here, na. That
This is blood
expect
pump.
this. I was asking to understand
Among the four.
Okay.
Okay.
That blood pump.
Blood pump is the highest. one.
Highest.
That way, you leave this and
Oh,
from
okay.
this. Okay. Because blood pump is per minute. Okay, 130 ml means in 60 ml you have to calculate.
Speed सबसे
Okay.
speed होती है.
सबसे स्पीड तो ब्लड पंप ही है. Okay, इसमें से कौन सा?
Effluent.
मैं कहाँ पे था? Okay, so 1300. Now the actual ultrafiltration happening in this filter is 1300 plus 400, 1700 plus 50, 1750 plus 20 ml apparent. 1770 is the ultrafiltration actually happening in this filter in hour. But from the patient it is taking only 50 ml. The remaining is which we are giving into the circuit as a replacement. Okay. So